Scope. An important idea in programming is scope. Scope defines where variables can be accessed or referenced. While some variables can be accessed from anywhere within a program, other variables may only be available in a specific context. You could think of scope like a view of the night sky from your window. Everyone who lives on the planet Earth is in the global scope of the stars. The stars are accessible globally. Meanwhile, if you live in a city, you may see the city skyline or the river. The skyline and the river are only accessible locally in your city, but you can still see the stars that are available globally. Over the next few exercises, we'll explore how scope relates to variables and learn best practices for variable declarations. Let's head to the next lesson. Blocks and scope. Before we talk more about scope, we first need to talk about blocks. We've seen blocks used before in functions and if statements. A block is the code found inside a set of curly braces. Blocks help us group one or more statements together and serve as an important structural marker for our code. A block of code could function like this. Const log sky color equals parentheses arrow function block let color equal blue console.log color. Notice that the function body is actually a block of code. Observe the block in an if statement. If dusk curly braces let color equal pink console.log color. In the next few exercises, we'll see how blocks define the scope of variables. Instructions. At the top of main.js, declare a const variable named city set equal to New York City. This variable will exist outside your block. Const city equals string capital New York City and run it. Below the city variable, write a function named log city skyline. Do they want us to do it with the const variable? I'm going to do it with the const, and we'll see what they say. So I put a fat arrow function there with the log city skyline variable. Let's take a look. That works for them. Inside of the body of log city skyline, write another variable using let named skyscraper and set it equal to Empire State Building. Let skyscraper all undercase equal Empire State Building. And we'll run that. Inside the function, include a return statement like this. So return the stars over the plus and then skyscraper. And you could see there's a space after the. I made a mistake with that. Make that space. Plus, we're going to have in and a space plus city. And that's that. It wants it like so. And run. Let's see what it is I did wrong here. Oh, I see. Okay, they need a space before in as well. That's where this stuff gets a little gotcha. That works. Beneath the log city skyline function, use console.log to log the value of log city skyline to the console. Okay, console.log log city skyline, the function. Oh, that's a G at the end. Line. And run that. That works perfectly. Let's move on to the next lesson. Global scope. Scope is the context in which our variables are declared. We think about scope in relation to blocks because variables can exist either outside of or within these blocks. In global scope, variables are declared outside of blocks. These variables are called global variables. Because global variables are not bound inside a block, they can be accessed by any code in the program, including code in blocks. Let's take a look at an example of global scope. Const color equals blue, const return sky color, return color inside the brackets should return blue. Even though the color variable is defined outside of the block and can be accessed in the function block, giving it global scope. In turn, color can be accessed within the return sky color function block. Let's work with global variables to see how data can be accessible from any place within a program. Instructions. At the top of main.js, write 3 global variables. Name the first variable satellite and set it equal to the moon. So let's say const satellite equals the moon. Const galaxy equals the Milky Way. And yes, there are 3 of these. We're just copying them down. Const stars equals North Star. And let's run that. That worked. Below the variables created in the previous step, write a function named callMyNightSky. Inside the function, include a return statement like this. We're going to copy it this time because there are quite a bit of spaces and so on here. So we want to write a function const callMyNightSky. I'm doing a lot of fat arrow functions, I know. I prefer them. And we want to return all of this. Let's try that out. That works. Beneath the callMyNightSky function, use console.log to log the value of callMyNightSky to the console. You'll notice that the function block for callMyNightSky is able to access the global variables freely since the variables are available in all lines of code in the file. Console.log callMyNightSky and as a function, and run that. And we can see right there, it is taking all the variables and making this a nice sentence I can print out. Let's go to the next one. Block scope. The next context we'll cover is called block scope. When a variable is defined inside a block, it is only accessible to the code within the curly braces. We say that variable has block scope because it is only accessible to the lines of code within that block. Variables that are declared with block scope are known as local variables because they are only available to the code that is part of the same block. Block scope works like this. Const log sky color is a function. Inside its block, it says let color equal blue. Console log color will equal blue. If you try to console log color outside of the function, you'll get a reference error. You'll notice we define a function log sky color. Within the function, the color variable is only available within the curly braces of the function. If we try to log the same variable outside the function, throws a reference error. The function throws a reference error is what they're trying to say right there. Instructions. In main.js, define a function. So const log visible light waves. And as a function, run that. Let's make sure I didn't have a typo in there. That works, must have been a typo. Within the log visible light waves function, using const, create a variable light waves and set it equal to moonlight. Const light waves equals moonlight, and run that. Within the log visible light waves function, beneath the light waves variable, add a console.log statement that will log the value of the light waves variable when the function runs. So console.log light waves. And then we'll run that. Call the log visible light waves function from outside the function. Console.log. I mean, we could just call it. I think they might mean just to call it. So it would be, let's copy it. So that's just calling it without the console. I think that's what they're asking. That is what they're asking. Beneath the function call, log the value of light waves to the console from outside the function. You'll notice that it logs a reference error since the variable is tied to the block scope of the function. So console.log, and it was light waves. And light waves is right up here, light waves. And yeah, there we go. I can't find it because it's within this block and it has a block scope. Let's go to the next one. Scope pollution. It may seem like a great idea to always make your variables accessible, but having too many global variables can cause problems in a program. When you declare global variables, they go to the global namespace. The global namespace allows these variables to be accessible from anywhere in the program. These variables remain there until the program finishes, which means our global namespace can fill up really quickly. Scope pollution is when we have too many global variables that exist in the global namespace, or when we reuse variables across different scopes. Scope pollution makes it difficult to keep track of our different variables and sets us up for potential accidents. For example, global scoped variables can collide with other variables that are more locally scoped, causing unexpected behavior in our code. Let's look at an example of scope pollution in practice so we know how to avoid it. You'll notice we have a variable num. Inside the function body of lognum, we want to declare a new variable but forgot to use the let keyword. When we call lognum, num gets reassigned to 100. The reassignment inside lognum affects the global variable num. Even though the reassignment is allowed and we won't get an error, if we decide to use num later, we'll unknowingly use the new value of num. While it's important to know what global scope is, it's best practice to not define variables in the global scope. Instructions. Let's see what happens if we create a variable that overwrites a global variable. Inside the callMyNightSky function, on the very first line of the function body, assign the variable stars to Sirius as such. Stars equals Sirius. And there we are with stars equals Sirius, and we'll run that. Night sky, the moon, Sirius, the Milky Way. Outside the function, under the current console.log statement, add another console.log statement to log stars to the console. Okay. Console.log stars. You'll notice that the global variable stars was reassigned to Sirius. In other words, we changed the value of the global stars variable, but it's not easy to read what exactly happened. This is bad practice in code maintainability and could impact our program in ways we do not intend. Let's run that. And we see that stars is now Sirius, even though it was North Star in the global scope. Let's move on to the next one. Practice good scoping. Given the challenges with global variables and scope pollution, we should follow best practices for scoping our variables as tightly as possible using block scope. Tightly scoping your variables will greatly improve your code in several ways. It will make your code more legible since the blocks will organize your code into discrete sections. It makes your code more understandable since it clarifies which variables are associated with different parts of the program rather than having to keep track of them line after line. It's easier to maintain your code since your code will be modular. It will save memory in your code because it will cease to exist after the code block finishes running. Here's another example of how to use block scope, as defined with an if block. Here you'll notice we create a variable dusk inside the log sky color function. After the if statement, we define a new code block with the curly braces. Here we assign a new value to the variable color if the if statement is truthy. Within the if block, the color variable holds the value pink, though outside the if block, in the function body, the color variable holds the value blue. While we use block scope, we still pollute our namespace by reusing the same variable name twice. A better practice would be to rename the variable inside the block. Block scope is a powerful tool in JavaScript, since it allows us to define variables with precision and not pollute the global namespace. If a variable does not need to exist outside a block, it shouldn't. Instructions. Inside the function body of log visible light waves beneath the region variable and before the provided console.log statement, create an if statement that checks if the region is the Arctic. Okay, add if statement here. If region triple equals the Arctic, and I'm not sure if it wants us to put the console.log in there or not. Let's try it without first. No, so let's put the console.log inside of there. Actually, that is right. The Arctic. I make a few extra typos when I'm talking and typing. There we go, that works. Inside the if block, define a new let variable, light waves, and set it equal to northern lights. So inside the if variable, we're going to let light waves equal northern lights. This should interfere with this. Let's take a look at what happens there. This changes the light waves from moonlight to northern lights. Beneath the variable in the if block, use console.log to log the value of the block variable inside the if block. The block variable inside the if block is going to be light waves. So let's console.log light waves. Okay. Beneath the variable in the if block, this is inside the if block. Run your code and notice the output. Inside the if block, console.log light waves logs the value northern lights. Outside, it does want it outside. Let's move you outside. I was going to say, both were doing the same thing. Run that. There you go. Northern lights, and outside it's moonlight. Run your code and notice the output. Inside the if block, console.log light waves logs the value northern lights to the console. Outside the if block, but still within the function, the same statement logs moonlight to the console. I see what they're saying. So outside of the if block, which is here, but still in the same function, is what they were trying to say. I gotcha. Okay, let's move to the next one. Review scope. In this lesson, you learned about scope and how it impacts the accessibility of different variables. Let's review the following terms. Scope is the idea in programming that some variables are accessible, inaccessible from other parts of the program. Blocks are statements that exist within curly braces. Global scope refers to the context within which variables are accessible to every part of the program. Global variables are variables that exist within the global scope. Block scope refers to the context within which variables that are accessible only within the block they are defined. Local variables are variables that exist within block scope. Global namespace is the space in our code that contains globally scoped information. Scope pollution is when too many variables exist in a namespace or variable names are reused. As you continue your coding journey, remember to use best practices when declaring variables. Scoping your variables tightly will ensure that your code has clean, organized, and modular logic. And that is that lesson. What is up next? We will be going over arrays.